Good evening, and welcome, wherever you are as you listen tonight, and however this quiet recording found its way to you. I'm very glad you're here. Perhaps you're already lying down, with the covers drawn up and the lamp turned low. Perhaps you've reached the end of a long and tiring day, or you're somewhere far from your own bed, in those small hours when almost everyone else has already gone to sleep. Before we begin, I'd love to know one small thing. Where in the world are you listening from tonight? If you feel like it, leave a few words below to say hello and tell us where you are. There is something quietly lovely in imagining so many people, scattered right across the world, all settling down to rest at the same time beneath the same wide sky. And if these calm recordings help you unwind and drift off, a gentle like and a quiet subscribe help this small channel more than you might think. Now, let me tell you where we're going to wander this evening. Tonight, our subject is the sun, that warm and familiar light that rises every morning without fail, that you have known since the day you were born, and yet have almost certainly never had the chance to sit and think about slowly, on purpose, the way we are going to now. We're going to travel all the way out to it, gently, in our minds. We'll find out how large it truly is, and how far away, and what it's actually made of. We'll go down into its deep and hidden heart, where its light is born, and follow that light on its long, slow journey out to your window. We'll look at its bright face, and its restless weather, and the faint crown of fire that only shows itself when the day goes dark. And at the very end, we'll wonder together about how the sun was born, and how, in the fullness of time, its story will one day come to a close. There's nothing here you need to follow closely. There's nothing to study, nothing to memorize, and there is certainly no test at the end. I hope this feels less like a lesson and more like a long, unhurried bedtime story about the nearest star, told softly in the dark. If you find yourself drifting off somewhere in the middle, long before we reach the end, please don't feel you've missed a thing. Drifting off is exactly what this is for, and it would be the loveliest possible way to spend the night. So make yourself as comfortable as you can. Sink a little deeper into the pillow, let your shoulders come down and soften, and let your eyes close whenever they're ready. Take one slow breath in, and let it gently out. And let us begin with the star that has been shining over you all your life. Let us start with the simplest and strangest fact of all, and it is this: the sun is a star. Not a lamp hung in the sky, not a warm circle painted on the blue, but a genuine star, exactly the same kind of thing as those tiny points of light you see scattered across the darkness on a clear night. The only reason it looks so different from them, so much larger and brighter and warmer, is that it is so very much closer. Every other star is so staggeringly far away that even the nearest of them shows up only as a faint speck. Our star sits right on our doorstep, and so it fills the whole day with light. It can take a moment to let that settle. When you look up at the night sky and see those thousands of distant suns, you are seeing the same kind of object that warms your face at noon. And when you feel the sun on the back of your neck on a summer afternoon, you are standing close to a star. Every one of those far-off points is a great burning ball of light, and many of them are larger than ours, and some are smaller, and around a great number of them there are very likely worlds of their own. But of all the countless stars in the sky, there is one, and only one, that we belong to. one that we circle year after year, one whose light grows our food and warms our seas and lifts our weather and lets us see the faces of the people we love. That one is ours. And what is a star really, when you come down to it? It is a huge ball of hot, glowing gas, holding itself together by its own weight, shining with a light made deep in its core. There is nothing solid about it at all. You could not stand on the sun, or land a boat on it, or set your foot upon its surface, because it has no surface in the way a rock or a planet does. It is gas from the outside all the way in, growing thicker and hotter and more crushing the deeper you go, until, at the very center, it becomes something almost past describing. A star is not a stone that happens to be on fire. It is a great glowing sphere of gas, an understanding that one idea unlocks nearly everything else we will talk about tonight. It might comfort you, oddly enough, to know that as stars go, our sun is really rather ordinary. It is not one of the giants, those rare and monstrous stars, hundreds of times wider than ours, that burn fierce and blue and live only briefly before they go. Nor is it one of the little ones, the small, cool, dim stars that far outnumber all the rest, glowing softly for spans of time longer than the universe has yet existed. Our sun sits comfortably somewhere in the middle of all of them, a plain, steady, yellow-white star of no particular fame, one of a truly staggering number of similar stars scattered through our corner of space. If some distant traveler far across the sky were to look toward us, they would see nothing remarkable at all, just another modest point of light among countless others, not worth a second glance. And yet that unremarkable little star is everything to us. It is the whole difference between a living world and a dead one. There is a gentle lesson in that, I think, that the most ordinary things, seen from close enough and loved enough, turn out to be the ones that matter most. There is one more thing worth saying gently before we go on. Our sun is not young, and it is not old. It is somewhere in the comfortable middle of its long life, about 4.5 billion years into a life that will last for many billions more. It has been shining steadily for longer than there has been an earth beneath it to shine upon, and it will go on shining, warm and dependable, for longer still than all of that again. So there is a kind of quiet reassurance in it. The star we are about to explore is not a fragile flame that might gutter out at any moment. It is a steady old fire, patient and reliable, that has kept its watch over this world since long before the first living thing drew breath, and will keep it long after tonight is forgotten. Let us go and get to know it. The first thing anyone wants to know about the sun is how big it is, and here we run straight into a difficulty, because the honest answer is a size the mind simply cannot picture. But let us try anyway, slowly, and see how far we get. The sun is round, a great glowing ball, and if you could somehow measure straight across it, from one side to the other, that width would be about 109 times the width of the earth. Picture that for a moment. Lay the whole earth down, from edge to edge, and then lay another beside it, and another, and keep going in a long line, and you would need more than 100 earths, set side by side, just to stretch across the face of the sun. And that is only across the middle. That is only the width. If instead you thought not about the width, but about the whole space inside, the difference becomes far greater still. In a way, that is genuinely hard to hold in your head. Because the sun is a ball, and a ball grows in every direction at once. The room inside it is much larger than the width alone would suggest. If the sun were a great hollow shell, and you tried to fill it up with earths, pouring them in like marbles into a jar, you would need not 100 of them, and not 1,000, but well over 1,000,000 earths to fill it. More than 1,000,000 whole worlds like ours poured into that one great sphere of light, and it would swallow every one. Our planet, which holds every ocean and mountain, and every living thing we have ever known, would be a single small grain inside it. And yet, for all that size, the sun does not fill our sky. It hangs up there looking no larger than the moon, a coin you could hide behind your thumb. And the reason for that is distance. The sun is far, far away, so far that even its terrible size is shrunk to a modest circle by the sheer gulf of empty space between us. That gap is about 93 million miles. It is a number so large that, again, it slides off the mind and refuses to mean anything. So let us try to give it a shape. Think of how fast the fastest thing you know can travel. If you could somehow set off from the Earth toward the sun in the swiftest passenger jet ever built, flying without stopping, day and night, never landing to refuel, it would take you not days and not weeks, but around 20 years of ceaseless flying to get there. A child born on the day you left would be grown by the time you arrived. That is how far away the sun is, and it is the very nearest star to us. All the others are so much farther that this distance, this 93 million miles that swallows a lifetime of flying, is nothing at all beside them, the merest first step out the front door. There is one traveller, though, that crosses that gulf with ease, and crosses it constantly, and that is light itself. Light is the fastest thing there is, faster than anything else can ever be, and even light, even at its blistering pace, takes about 8 minutes to come all the way from the sun to your eyes. Hold on to that thought, because it is a lovely one, and we will return to it later tonight. When you step outside into the morning and feel the warmth land on your skin, that warmth did not leave the sun just now. It set out about 8 minutes ago and has been racing across all that empty dark ever since, only to arrive, at last, on your upturned face. There is another way to feel the size of the sun, and it is worth a quiet moment, because it is not only wide, but heavy beyond all reckoning. If you could somehow gather up everything in our whole neighborhood of space, every planet great and small, every moon, every drifting comet and tumbling stone, and weigh them all together in one enormous pile, that whole pile would still be the merest crumb beside the sun. The sun holds within itself more than 99 parts in every 100 of all the material there is anywhere near us. Everything else, the Earth and all its sister worlds included, is just the little that was left over, the faint scattering of dust around a single, overwhelming weight. When you think of our corner of space, it is truer to picture it not as a family of equals, but as one great heavy sun, with a few tiny specks going round it. And it is exactly that great weight that keeps us here. The Earth does not drift off into the dark, and neither do any of the other worlds, because the sun's weight reaches out invisibly and holds them, the same gentle, patient pull that keeps your feet on the ground and draws a drop cup toward the floor. The sun is so heavy that its pull stretches out across all those millions of miles and keeps the Earth swinging steadily around it, year after year, never falling in, never flying away, tracing the same wide and faithful circle that gives us our seasons and our years. Every birthday you have ever had marks one more full journey around that heavy holding star. So the sun is not only our light and our warmth. It is the anchor of our whole world, the still center we have been circling since long before you were born. We have said the sun is a ball of hot glowing gas, but let us slow down and ask what that gas actually is, because the answer is beautifully simple, and it connects the sun to nearly everything else in the sky. The sun is made, for the most part, of the two lightest and most basic substances there are. The first, and by far the most plentiful, is hydrogen. It is the simplest stuff in all the universe, the very first thing that existed in any great quantity, and it makes up the great bulk of the sun. Wherever you look in that huge glowing ball, you are looking mostly at hydrogen. The second substance, making up most of what remains, is helium, which is the next simplest thing after hydrogen and lighter than air. The same gas that lifts a balloon and floats it gently to the ceiling. Beyond those two, there are only faint traces of anything else at all, small pinches of the heavier substances scattered thinly through the mix. Now, when I say hydrogen and helium, you might picture a cool, quiet gas, the sort of thing you could breathe or hold in a jar. But the gas of the sun is nothing like that, because it is so fearsomely hot. When gas is heated to the temperatures found inside a star, it changes into something that behaves quite differently, a hot, glowing, restless state of matter that scientists give a special name to, though the name matters far less than the picture. Think of it simply as gas so hot that it has come apart at the seams and turned into a shining electric soup, crackling with energy, churning and flowing. That is the true stuff of the sun. Not flame, not fire in the ordinary sense, but this hot, bright, seething gas, from the surface all the way down to the core. Here is a fact that surprises almost everyone, and it says something about how strange the sun really is. Taken as a whole, all the way through, the sun is not especially heavy for its size. Averaged out across that entire glowing ball, its gas is only a little heavier than water, so that if you could somehow weigh a bucketful of average sun, it would not weigh very much more than a bucket of water from your own tap. And yet that gentle average hides a fierce extreme, because the gas of the sun is spread so unevenly. Out near the surface, it is thinner than the air you are breathing, wispy and faint, while down at the very center, it is squeezed to a density many times greater than any metal you could name, denser than lead, denser than gold, though it is still, remarkably, a gas. So the sun is at once feather light and crushingly heavy, depending only on where you look, thin as a breath at its edge and packed beyond all solids at its heart. And here is a thing worth pausing on. There is no solid part of the sun anywhere, not a rocky core, not a hard shell, not a single place you could set your foot. It is this glowing gas throughout, growing thicker and heavier as you sink deeper, the way the water in the sea grows heavier and darker the deeper you dive, but never turning to stone, never becoming ground. If you could somehow fall into the sun and survive the heat, which of course you could not, you would simply keep on falling through hotter and denser and more crushing gas, with no floor ever to meet you. The sun is a bottomless ocean of light. You might reasonably wonder how anyone could possibly know what the sun is made of, when no one has ever been there, and nothing we could send would survive the journey. The answer is one of the cleverest and most beautiful tricks in all of science, and it hides in the light itself. When you take the light of the sun and spread it out carefully, the way a raindrop spreads sunlight into a rainbow across the sky, something remarkable appears. The spread out band of color is crossed here and there by thin dark lines, narrow gaps where certain colors are quietly missing. And it turns out that each kind of substance in the universe drinks up its own particular set of colors, leaving its own pattern of dark gaps behind, as unmistakable as a signature or a set of fingerprints. So by reading the pattern of missing colors in the sun's light, patiently, line by line, we can tell exactly what the sun is made of without ever leaving the ground. We simply read its light like a message, and the message says hydrogen and helium, and only faint traces of anything more. There is a lovely story tucked inside that too. Helium, the second most plentiful substance in the sun, was actually noticed there first, in the sun's own light, before anyone had ever found a scrap of it here on Earth. Watchers studying the sun during an eclipse saw a line of color that matched nothing then known, and realized they were looking at the fingerprint of a substance no one had yet met. They named it after the sun itself, borrowing the old word for our star, so that its very name means, more or less, the sun's own stuff. Only years later was the same substance finally found down here at home. It is a gentle reminder that the sun is not only something to be warmed by, but something to be read, a book of light astronomy that has been quietly telling us its secrets all along, if only we knew how to look. It is a wonderful thought, really, that something so grand and so powerful, the ruler of our whole day, is built almost entirely out of the two plainest ingredients in creation. There is no rare or precious material at its heart, no secret fuel of some exotic kind. It is hydrogen and helium, the humblest substances there are, gathered together in such staggering quantity and squeezed so hard by their own great weight that they blaze. And this is not special to our sun. Nearly every star you have ever seen is made of the very same simple stuff, glowing in the very same way. The recipe for a star is almost embarrassingly plain. Take the lightest gas in the universe, gather enough of it together in one place, and let its own weight do the rest. The wonder is not in the ingredients. The wonder is in what happens when you pile up enough of them, which is exactly where we are going next, down into the heart of the sun. Come with me now, in your imagination only, down beneath the bright face of the sun, sinking through layer after layer of that glowing gas, down toward the very center. As we go, everything grows more extreme. The gas above us presses down with ever greater weight, so the deeper we sink, the more crushingly it is squeezed together, and the hotter it becomes. And at last, right at the middle, we arrive at the core, the deep heart of the sun, where the whole story of its light begins. The core is a place of conditions so far beyond anything in your experience that words can only gesture at them. The temperature there is about 15 million degrees. Not 15 degrees, not 1500, but 15 million. A heat so far past anything you have ever felt or feared that comparison falls apart. And the crushing is just as extreme as the heat. The entire weight of the sun, all those hundreds of thousands of miles of gas above, presses down upon the core, squeezing it to a density far greater than any solid you have ever handled, even though it is still, strictly speaking, a gas. It is heat and pressure together, both turned up beyond all reckoning, and it is exactly this combination that lets the sun do the remarkable thing it does. For the core of the sun is where the light is made, and it is made in a way that took people a very long time to understand. Here is what happens, told as gently as I can. Deep in that core, the hydrogen is squeezed so hard and heated so fiercely that the tiny pieces of it, the smallest specks the gas is built from, are rammed together with tremendous force. And when 4 of these smallest pieces of hydrogen are driven together and made to join, they become something new. They stick together into a single piece of helium. In the joining, a small amount of their substance is not carried over. It does not simply vanish, but is released instead as a flash of pure energy, a burst of light and warmth. This joining together of the tiny pieces is called fusion, and it is the deep secret of every star. The sun shines because in its heart, hydrogen is endlessly being fused into helium, and each joining sends out a little pulse of energy. Do this countless times over, every fraction of every second, and you have the light of the sun. There is a quiet balance here too, that is worth pausing on, because it is the reason the sun holds itself so steady, year after year, without swelling up or falling in. On the one hand, the whole crushing weight of the sun is forever trying to fall inward, every part of it pulled toward the center by that same patient tug we have spoken of, pressing down, wanting to collapse the whole star into a single point. On the other hand, the furnace burning in the core pushes outward with tremendous force, the heat and light of all that fusion straining to blow the star apart. And these two, the crushing inward and the pushing outward, are almost perfectly matched. They hold each other in a gentle standoff, the weight forever falling in and the fire forever pushing back, so that the sun neither collapses nor explodes, but simply hangs there in balance, burning calmly and evenly for billions of years. It is a bit like a great tent held up by the wind inside it, the fabric pulled down by its own weight and pushed up by the pressure within, settling into a shape that holds. The steadiness of the sun, the very thing that lets us count on it, is that balance, quietly kept, moment by moment, for longer than the mind can hold. And the scale of it is difficult to take in. To keep itself shining as brightly as it does, the sun fuses something like 600 million tons of hydrogen every single second. Every second, a weight of hydrogen greater than a mountain is turned into helium and light, and then the next second it happens again, and the next, without pause, without rest, and it has been doing this for 4.5 billion years. And yet the sun is so enormous, holds so much hydrogen in its great body, that even burning through it at that furious rate, it has enough to keep going for billions of years more. That is the strange arithmetic of a star. A furnace burning mountains by the second, with fuel enough to last longer than we can rightly imagine. It is worth sitting for a moment with the sheer patience of it. This joining of hydrogen into helium does not happen in a rush, for all the fury of the core. Any single speck of hydrogen may drift about in that furnace for an immense span of time, ages upon ages, before it finally meets its partners in just the right way and joins with them. The sun is in no hurry at all. It burns slowly, carefully, doling out its light a little at a time, which is the very reason it can last so long. A fire that burned all its fuel at once would flare up brilliantly and be gone in a moment. The sun does the opposite. It holds itself back, releasing its energy with such restraint that a single store of hydrogen can keep it shining steadily for many billions of years. So the calm, unchanging sun you have known all your life is calm precisely because, deep down, It is so unhurried, so patient, so slow to spend what it has. There is one more piece to this, and it is my favorite part, because it is so quietly astonishing. By all rights, fusion should be even harder to start than it is. The tiny pieces of hydrogen do not want to join. They push away from one another, resisting, refusing to touch, and even the tremendous heat and pressure of the core are not quite enough, on their own, to force them the whole way together. And yet the sun shines. It shines because of a curious rule that governs the smallest things in the universe. A rule that says a tiny particle is never fixed in exactly one place, but is always a little blurred and uncertain, so that now and then it can turn up on the far side of a barrier it never had the strength to cross. It is as though the particle, unable to climb over the wall between it and its neighbor, simply flickers and appears on the other side. This gentle blurring, this quiet trick of the very small, is what lets fusion happen at all. Without it, the core would be too cool and too weak to burn, and the sun would not shine. So the light that warms your face tonight exists because the smallest pieces of the world are allowed, ever so slightly, to be in more than one place at once. I find that a wonderful thing to rest a mind upon. So the light of the sun is born deep in the core, in that furnace of fusion, 15 million degrees hot and crushed beyond imagining. Now here is a question you might not have thought to ask, but which has a beautiful answer. Once a flash of energy is made down there in the heart of the sun, how long does it take to get out? How long from its birth in the core to the moment it leaves the bright surface and heads off into space? You might guess it happens in an instant. That light being so fast, it simply shoots straight out. But it does not. In fact, it takes an amount of time so long that it is one of the most surprising facts in all of this story. The trouble is that the inside of the sun is packed so densely with gas that a newborn flash of energy cannot travel in a straight line for more than the tiniest distance before it runs into something and is swallowed up. It is absorbed almost at once by a piece of the crowded gas, and then, a moment later, spat back out again, but in some new and random direction, this way or that, with no memory of where it was going. And then it travels another tiny distance, and is swallowed and thrown out again, in yet another direction. And so it goes on and on endlessly. The energy does not stride out of the sun. It staggers, like someone trying to cross a vast and crowded room in the dark, bumped and turned at every step, knocked backward as often as forward, wandering a long and looping path that only very, very slowly works its way outward toward the light. How long does that wandering take? Here I have to be honest with you, because it is one of those things where the careful answer is a range rather than a single number, and the experts do not all agree. The gentlest thing we can say is that it takes a truly long time, far longer than you would ever guess for something as quick as light. Some careful estimates put it at many thousands of years. Others, working the sums a different way, arrive at figures far longer still, hundreds of thousands of years for a flash of energy to make its long, staggering climb from the core to the surface. The exact number depends on assumptions no one can fully pin down, so let us simply hold the honest shape of it. It is a journey measured not in seconds or hours, but in ages, an outward crawl through the crowded body of the sun that takes longer than there has been human history. There is a strange and gentle exception to all this, one small kind of messenger that does not stagger at all. Along with the light, the fusion in the core makes a great flood of tiny, ghostly particles, so faint and so slight that they barely notice ordinary matter is there. To them, the whole dense body of the sun is almost as good as empty space, and they slip straight through it all without being stopped, escaping the core and flying free in a matter of seconds, while the light they were born alongside is only just beginning its long imprisonment. These little ghosts stream out of the sun in unthinkable numbers, and they are passing through you right now as you lie there, countless of them, pouring through your body every single second, day and night, without your ever feeling the faintest thing. They pass through the earth as though it were not there, through your walls and your blanket and your bones, silent and harmless and unnoticed, fresh messengers from the very heart of the sun. It is a curious comfort, in a way, to know that the deep core of a star is pouring gently through you as you rest, and has been all your life. And then, at last, that battered, ancient energy reaches the surface, and everything changes. It bursts free of the crush, out into open space, and now, with nothing left to bump into, it flies. It crosses the whole 93 million miles from the sun to the earth in about 8 minutes. That same swift 8-minute crossing we spoke of earlier. So here is the thought I promised you, and it is a lovely one to hold in the dark. The sunlight that warms your face, the light that fills your window in the morning, was born deep in the heart of the sun a very long time ago. It spent an age, perhaps longer than all of recorded history, wandering slowly outward through the crush toward the surface, and then only its final leap, the last 8 minutes, was spent crossing the space to you. The warmth on your skin is old, far older than you, older than your whole kind. It set out on its journey long before there was anyone here to feel it, and it has been coming to meet you, patiently, ever since. Let us come back up now, out of the deep interior, and rest our attention on the surface of the sun, the bright face that we see, the part that gives us our daylight. We must never look straight at it, of course, for its light is far too fierce for our eyes to bear, and even a glance can do harm. But we can think about it gently and picture what it is truly like up close, and it turns out to be a place of restless, churning beauty. The surface of the sun is far, far cooler than that terrible core, though cool is a strange word to use for it. It is around 5,500 degrees, which is still hot beyond anything on Earth. Hot enough to turn any metal you know to vapor in an instant. But set against the 15 million degrees of the heart, the surface is almost mild, a comparatively gentle skin over that deep furnace. And this bright skin is not smooth or still. If you could see it up close, it would be seething, forever in motion, covered all over with a shifting, bubbling pattern, like the surface of a pot of soup left simmering on the stove. That bubbling comes from the way heat rises through the outer layers of the sun. Deep down, hot gas swells and grows lighter and pushes upward toward the surface, carrying the sun's warmth with it, just as hot water rises in a pot. When it reaches the top and spills out its heat into space, it cools and grows heavier, and sinks back down again to be warmed once more, and up it comes again, over and over. So the whole face of the sun is covered in countless great rising and falling cells of gas, bright where the hot gas wells up, a little darker where the cooler gas sinks back, giving the surface a grainy, restless, ever-changing look. And each of these gentle-sounding bubbles is truly the size of a country, a churning cell of glowing gas, wider than a great many nations, rising and falling in a slow and stately motion that only looks small because the sun itself is so huge. There is a particular color to that light too, which is worth a gentle word. The sun's light, taken all together, is very nearly white, a full and even blend of every color there is, which is exactly why sunlight can be split into a whole rainbow. We often draw the sun as yellow and paint it gold in our pictures, and there is a kindness in that. But its true light, seen from above our air, is a clean and balanced white, the color of all colors mixed as one. The warm golden tint we so love is mostly the doing of our own air, which gently filters the light on its way down to us, especially when the sun rides low, so the plain white light of the star becomes the honeyed glow of a late afternoon only once it has passed through the thin blanket of air we live beneath. And then, scattered across that bright and bubbling face, there come and go the dark marks we call sunspots. If you have ever seen a safe photograph of the sun, you may have noticed them, small dark blemishes on the shining disk, sometimes alone, sometimes in little groups. They look black in the picture, but they are not truly dark at all. They only appear dark because they are cooler than the blazing gas around them, and so they shine less brightly by comparison, the way a candle looks dim if you hold it up against the glare of a bright window. A sunspot is a patch of the surface that has been held back from its usual heat, cooled by forces welling up from within, so it glows a little less than its surroundings and shows up as a dusky mark. And though they look like specks, many a sunspot is larger across than the whole Earth. Watching those spots taught us something else too, something you might not have guessed. The sun turns. It spins slowly around, the way the Earth does, though far more grandly, and we can see it turning precisely because the sunspots are carried along with it, drifting slowly across the face from one side to the other, disappearing around the far edge, and in time coming back into view on the near side again. By following the spots on their patient march, people long ago worked out that the sun takes something like 25 days to turn once, all the way around. A slow and stately rotation, far more leisurely than our own quick spinning day. And the sun does something odd as it turns, something no solid ball could do. Being made of gas, it does not turn all in one piece. Its middle sweeps around a little faster than its top and bottom, so that different parts of the sun keep slightly different time, sliding gently past one another as they go. That may sound like a small curiosity, but hold on to it, for it turns out to lie at the very root of the sun's restlessness, as we shall see in a little while. The sunspots do more than travel with the turning sun, though. They come and go over time as well, and here is the loveliest part. Their comings and goings follow a rhythm. Over a span of about 11 years, the sunspots slowly build up in number until the face of the sun is freckled with them. And then, over the following years, they fade away again until the disk grows almost clear. And then, slowly, they begin to return, and the whole cycle repeats over and over, a patient tide of spots rising and falling on a rhythm of roughly 11 years. It is the sun's own slow seasons, if you like, a steady heartbeat of activity that has been keeping its time for as long as anyone has watched, and long before. That rhythm of the sunspots is a clue to something larger, which is that the sun is not a calm and steady lamp at all, but a restless, active, weather-filled world in its own right. We tend to think of it as changeless, the same reliable circle every day. And in the ways that matter to us, it is dependable. But up close, the sun is forever stirring, and now and then it stirs quite dramatically, and those stirrings reach all the way across space to touch us here. The source of all this restlessness is something invisible that runs through the sun and wraps around it, a kind of force woven through its gas, the very same force that turns the needle of a compass and holds a magnet to the door of a refrigerator. In the sun, this force is tangled and looped and endlessly twisted about by the churning of the gas and the turning of the great body itself. And because the sun does not turn all in one piece, but spins faster around its middle than near its top and bottom, this invisible force gets wound up tighter and tighter over time, stretched and knotted and stored up, like a rubber band twisted round and round until it strains. The sunspots are the places where these tangled loops of force break through the surface. And when the strain grows too great, and one of those knots suddenly snaps and rearranges itself, an immense amount of stored up energy is released all at once. Sometimes these tangled loops of force do something gentler and even more beautiful. They arch up off the surface of the sun and hang there, holding aloft a great curved bridge of glowing gas, a shining loop or ribbon suspended high above the face of the sun, standing in the emptiness like a fountain frozen in the act of falling. These great arches can hang there for days at a time, quietly glowing, some of them so large that you could line up many whole earths beneath them and still have room to spare. They are among the grandest structures in all the sun, and they trace out, in glowing gas, the very shape of that invisible force running through the star, drawing its hidden loops for anyone who has the eyes to see them. And then, when the balance shifts, one of these great arches may lose its footing all at once. When that happens, the sun can loose a sudden flash of brilliance, a flare, a burst of light and energy leaping off its surface, brighter for a moment than anything around it. And sometimes, along with the flash, the sun flings off a great cloud of its own gas, hurling a huge billow of glowing material out into space, away from itself and off across the dark. These great eruptions send out an expanding cloud of tiny particles, racing outward, and if one happens to be aimed our way, it comes sweeping across the 93 million miles toward us, and eventually washes over the earth. It sounds alarming, and long ago it might have seemed so. But I want to frame it gently, because our world is well protected, wrapped in its own invisible shield and its blanket of air. And these gusts from the sun mostly break harmlessly against that protection, far above our heads. In fact, even when they are still and quiet, when there is no flare or eruption at all, the sun is always breathing outward. It gives off a steady, endless stream of tiny particles in every direction, all the time. A faint and ceaseless wind blowing out from the sun and off across the whole solar system. We call it the solar wind, and it never stops. It has been blowing gently and constantly for the whole life of the sun, streaming past the earth and onward, out beyond the farthest planets. And when that wind, or one of those great gusts, meets the earth's invisible shield, it is mostly turned aside, guided harmlessly around us. But a little of it is drawn down toward the very far north and the very far south toward the top and bottom of the world. And there, high up in the sky, it meets the edge of our air and sets it aglow. That glow is the polar lights, those soft, shifting curtains of green and rose and violet that ripple across the northern and southern skies on certain nights. They are, quite literally, the wind of the sun, made visible where it brushes against our world what might have seemed a hazard becomes in the end one of the most beautiful sights the sky has to offer. The sun reaches out to touch us, and where it does, the heavens light up in color. That 11-year rhythm of the sunspots, by the way, is only the visible half of something deeper and slower. The invisible force running through the sun does not merely rise and fall in strength. Over the long run, it actually turns itself completely around. What was the sun's north settles into its south, and the whole great pattern of the force reverses, and then, over the following years, it reverses again, back to where it began. It is a slow and stately turning over of the entire star, taking about twice as long as the visible cycle of the spots to come full circle, so that the freckling of the face we can watch is really the outward sign of a far grander rhythm, playing out unseen within. There is something soothing in the thought of it, a great slow heartbeat of magnetism, patiently reversing and returning, over and over, through all the long ages of the sun's life. There is a gentler, more modern side to this too. That same restless activity, those same gusts of particles, can now and then reach down and ruffle the machines we have come to rely on. The spacecraft that circle above us and the delicate systems we have strung across our world. It is a small disturbance, watched carefully by people whose task it is to keep an eye on the sun's moods so that we can be ready. But there is nothing in it to keep you awake tonight. It is simply the nearest star, being what it has always been, alive and stirring and never quite still, and us, learning slowly to live alongside its weather. Now I want to tell you about one of the most beautiful and most puzzling parts of the whole sun, a part you almost never get to see, and a part that hides a genuine mystery that no one has yet fully solved. Above the bright bubbling surface of the sun, there is more sun still. There is a faint outer atmosphere, a thin and wispy halo of gas that reaches far out above the surface, glowing softly, far too dim to see against the dazzle of the bright disk below it. It is there all the time, but the ordinary light of the sun drowns it out completely, so we live our whole lives beneath it without ever glimpsing it. This outer halo is called the corona, a word that simply means a crown. And a crown is exactly what it looks like. There is only one time in the ordinary course of things when you can see this crown with your own eyes, and it is one of the rarest and most moving sights in all of nature. It happens during a total eclipse of the sun, on those uncommon occasions when the moon passes exactly in front of the sun and covers its bright face completely, blotting out the dazzling disk for a few short minutes. When that happens, and the fierce light of the surface is hidden away behind the moon, the faint crown around it suddenly leaps into view, a soft, pearly halo of light streaming out from behind the dark circle of the moon, pale and delicate and shimmering, reaching out in gentle streamers on every side. People who have witnessed it often speak of it as one of the most beautiful things they have ever seen, and many are moved to tears. For a few minutes, in the middle of the day, the sky goes dark, and the sun puts on its crown of quiet fire. And here is the mystery, the genuine and honest puzzle that hides in that crown. You would expect that as you move away from the hot surface of the sun, out into the thin gas of the corona, things would grow cooler. That is only sensible. Move away from a fire, and you feel less of its heat. The surface of the sun is around 5,500 degrees, and you would naturally think the faint gas floating above it would be cooler still. But it is not. It is hotter. Far, far hotter. The corona, that thin outer crown, is not thousands of degrees but millions of degrees, hundreds of times hotter than the surface it floats above. Somehow, as you leave the surface and move outward, the temperature does not fall. It climbs steeply to a searing heat that has no business being there. It is as though you stepped back from a campfire and found the air growing warmer the farther away you moved, which makes no ordinary sense at all. I want to be very clear and very honest with you about this, because it matters. This is not a puzzle that has been quietly solved and simply not mentioned. This is a real and open question in the science of the sun, one that has stood unanswered for many decades, since it was first properly recognized in the years before the Second World War. Scientists have a name for it. They call it the coronal heating problem, and it is exactly what it sounds like. We do not fully know how the corona gets so hot. It is one of the true unsolved riddles about the star right next door, and I find something rather wonderful in the fact that such a mystery still sits there, in plain sight, above a thing we see every single day. The crown is not a still thing either, but forever streaming, its faint gas reaching out and out until, far from the surface, it stops being an atmosphere at all and simply becomes that endless outward wind we have spoken of, blowing off across space. So the crown you glimpse for those few precious minutes of an eclipse is really the beginning of something that reaches all the way out past the planets. The soft streamers you would see around the darkened sun are the very first stretch of the wind that will one day blow past the Earth and onward to the edge of everything. And the shape of that crown is never quite the same twice. When the sun is quiet, its crown is smooth and even, reaching out in long, gentle plumes. When the sun is restless and covered in spots, its crown grows wild and ragged, streaming out in every direction at once. To see it at all is a rare gift, granted only in those few dark minutes when the moon stands exactly right, and no two people who have seen it ever quite describe it the same way. There are ideas, of course, good and careful ideas, and I will share them gently, but I will not pretend they are the settled answer, because they are not. One leading thought is that the corona is heated by countless tiny flares, small sudden bursts of energy, far too small to notice one at a time, going off constantly all across the sun, a ceaseless peppering of little explosions that together keep the crown searingly hot. Another leading thought is that waves of energy, ripples running up through the tangled invisible force of the sun, carry heat outward from the surface and dump it into the corona, the way a wave breaking on a shore delivers its energy all at once. Perhaps it is one of these. Perhaps it is both together. Perhaps it is something we have not yet properly imagined. Even now, careful spacecraft are flying closer to the sun than anything ever has before, diving through the very edges of that crown, gathering what clues they can. But for tonight, the honest and rather lovely truth is simply this: the sun wears a crown of fire hotter than its own face, and no one yet knows quite how it is lit. We have spoken of the solar wind, that steady breath of tiny particles streaming outward from the sun in every direction, without pause, for the whole of its long life. I would like to follow that wind now, out past the earth, out past everything, and show you just how far the sun's reach truly extends, because the sun is not merely a light in our sky. It is the ruler of a realm far larger than most people ever picture, and that realm is shaped, out to its very edges, by this ceaseless outward wind. The solar wind does not stop at the earth. It sails right past us and keeps going, out to the other planets, out past the rings of the great gas worlds, out past the small and icy bodies that circle far from the warmth, and onward still into the deep cold beyond all the planets. As it flows outward in every direction, it inflates a huge invisible bubble around the whole sun and everything that circles it, a great rounded region carved out of the emptiness between the stars, kept swept clear and filled by the sun's own breath. Everything we think of as our neighborhood in space, the sun and all its planets and moons and comets and drifting stones, sits deep inside this great bubble, cradled within the reach of the solar wind. It is difficult to convey how large this bubble is, so let us go back to light, our patient measuring stick. Remember that the sun's light takes about 8 minutes to reach the Earth. Well, the edge of this great bubble, the place where the solar wind finally runs out of push and gives way to the thin gas that drifts between the stars, is so far out that the sun's light takes not 8 minutes to reach it, but many, many hours. The wind streaming from the sun has to blow across a distance so great that even the farthest, coldest, most sluggish planets are still, in a sense, close to home, huddled near the middle of a realm that stretches vastly farther out than any of them. This great bubble is not a perfect round ball either, and the reason is rather charming. The sun itself is not sitting still. It is drifting slowly through the thin gas that lies between the stars, carrying its whole family of worlds along with it on a long, slow voyage. And as it travels, its bubble is gently shaped by that motion, pressed in a little at the front, where it pushes against the gas ahead, and drawn out into a long, soft, trailing wake behind, so that the whole thing takes on something of the shape of a raindrop or of a great, slow comet, with a rounded nose in front and a gentle tail streaming out behind. So we are not merely circling a star. We are riding along inside a vast, soft, invisible vessel, nosing its way forever forward through the dark between the stars, with the sun at the helm, and all of us tucked safely within. We know this bubble is real, and roughly where its edge lies, because we have actually reached it. Long ago, we sent a small handful of spacecraft off on one-way journeys, away from the sun, out past all the planets, and they have simply kept going, year after year after year, for decades now. And after all that time, traveling outward the whole while, a couple of them have finally crossed the outer boundary of the sun's bubble and passed beyond it, into the space between the stars. They are the farthest things human hands have ever made, still faintly whispering back to us across that great gulf, and it took them a working lifetime of steady travel just to reach the edge of the sun's domain. That is the reach of our star, not to the Earth, not to the farthest planet, but out and out and out, wrapping a bubble around the entire family of worlds, a quiet kingdom of wind and light with the sun enthroned at its heart. And you, lying there tonight, are deep inside that kingdom, near its warm center, sheltered within the reach of the star we have been getting to know. The same wind that carves the far edge of the bubble, hours of light travel away, is blowing gently past your world this very moment, held off by the Earth's invisible shield, kept from you and yet all around you. It is a strange and homely thought that our whole familiar sky, everything we can see and everything we cannot, is held inside the breath of a single star. We have traveled a long way out, to the very edge of the sun's reach. Let us come all the way home now, back to the earth, back to your window and your garden, and the green world outside your door, and think for a while about what the sun actually gives us. Because for all its size and mystery, the sun's greatest role in our lives is the gentlest and most everyday one. It is the giver of nearly all our warmth and nearly all our light, and in a way you may not have fully considered, very nearly all of our food and energy as well. Almost everything that makes the earth a living world traces back, in the end, to sunlight. Start with the simplest gift, the warmth. The earth would be a frozen, lifeless stone without the sun, a dark ball drifting cold in the black, far below the temperature at which anything could live. It is the sun, and the sun alone, that keeps our world warm enough for liquid water to pool and flow, warm enough for oceans instead of solid ice, warm enough for a soft, breathable air, and for the gentle span of temperatures in which living things can thrive. Every warm day you have ever enjoyed, every mild evening, every patch of sunshine you have turned your face toward, is a gift of heat sent across 93 million miles of empty space to reach you. Take the sun away, and within a short time the whole world would freeze solid, from the poles to the middle, and all its water would turn to stone-hard ice. Then there is the food, and here is where the sun's gift becomes truly remarkable, once you see how it works. Think of a green plant, a blade of grass, a leaf on a tree, a stalk of wheat in a field. Every green growing thing has a quiet trick, the most important trick on earth. It catches sunlight, and it uses the energy in that light to build itself, to make the very substance of its leaves and stems and roots out of nothing more than light, air, and water. The energy of the sun is captured and stored away inside the plant, folded into its living tissue. And then, when a creature eats the plant, that stored sunlight becomes the energy that moves its body. And when another creature eats that one, the sunlight passes onward again. Trace any meal you have ever eaten back to its beginning, and you will arrive, sooner or later, at a green plant catching the light of the sun. The energy that lets you move and think and breathe right now was sunlight not so long ago, gathered by growing things and passed along to you. You are, in the most literal sense, running on sunshine. And here is a deeper turn of that same idea, one that reaches back across ages. Much of the energy that has powered our modern world, the coal that fed the old furnaces, the oil and the gas that drive so many of our engines, is nothing other than ancient sunlight, caught and stored and buried long ago. Deep in the past, green and growing things gathered the light of the sun into themselves, just as plants do today. And when they died and were buried and pressed down under the weight of ages, the sunlight they had captured was locked away with them, hidden underground for great stretches of time, until at last we dug it up and set it free again. So when an old lamp was lit, or an engine turned, it was very often running on sunshine that fell upon the earth long before there were any people to feel it, saved up in the dark all this time. The warmth of ancient afternoons has been quietly lighting our nights. And it does not stop there. Think of the weather, the whole restless dance of wind and cloud and rain. That too is the work of the sun. The sun warms the seas, and the warmth lifts water invisibly into the sky, where it gathers into clouds and drifts on the wind and falls again as rain and snow, watering the land, filling the rivers, feeding every field and forest. The sun warms some parts of the world more than others, and that unevenness is what stirs the winds and drives the great turning of the weather across the whole face of the planet. Even the flowing of the rivers and the blowing of the wind are, if you follow them back, the sun at work, lifting and stirring and setting the whole world gently in motion. There is something even closer to home in all of this, something written into your very body. For as long as there have been living things, they have kept their time by the sun. Deep inside you, quietly, there is a kind of inner clock that runs on the daily rhythm of light and dark, rising and falling with the coming and going of the sun. It is what makes you feel wakeful when the morning light returns, and heavy and ready for rest as the evening dims. The very drowsiness stealing over you now, as the world outside grows dark, is part of that old agreement between your body and the sun, an arrangement handed down through countless generations of living things, all of them tuned to the turning of the light. You do not have to think about it. It simply happens, gently, as it always has. The sun setting somewhere over the edge of your world, and your body answering softly that it is time to sleep. And even the colors of your day are the sun's quiet gift. The blue of the sky overhead is nothing but sunlight, scattered and spread across the air above you, painting the whole dome of the day. And those deep golds and soft roses of the evening, the colors that pour across the sky as the sun goes down, are the same light, reaching you now through a longer slant of air, its gentler shades set glowing along the edge of the world. Every sunrise you have ever watched, every sunset that ever made you stop and look, was the sun's light playing across the thin skin of air around our world, a small daily wonder freely given that we so easily forget to notice. So the next time you feel the sun on your skin, or watch it slant golden through a window in the late afternoon, you might let yourself remember all of this. That warmth is not a small thing, not a mere pleasant sensation. It is the source. It is the reason there are oceans and not ice, the reason there is grass and grain and fruit, the reason there is weather and rain and running water, the reason there is breath in your chest and strength in your limbs. Nearly every good and living thing on this earth is, when you trace it home, a gift of sunlight, handed down from that steady old star across all those miles of empty dark, freely, without cost, morning after morning, for as long as there has been a morning at all. We have come to know the sun as it is now, in the long middle of its life. But it was not always here, and I would like to tell you gently the story of where it came from, because it is a story of great patience and great quiet, and it belongs to us as much as to the sun, for we were made from the same cloud. To find the sun's beginning, we have to go back a very long way, about 4.5 billion years, to a time before there was any sun at all, and before there was any earth beneath it. In that time, in the place where our sun would one day shine, there was only a great cloud, drifting in the dark between the stars. It was made of gas, mostly that same simple hydrogen, and threaded through with a fine dust, and it was cold and thin and dim, spread out across a space far larger than you could picture. There was nothing bright about it, nothing warm, no hint of the fierce star it would become. It was just a soft, dark, slowly drifting haze, one of many such clouds scattered through the space between the stars, quietly waiting, though it was waiting for nothing in particular. For ages upon ages, it simply hung there in the cold and the dark. What first set the whole thing in motion, after all those ages of stillness, we cannot say for certain, and it is honest to admit it. One thought that many who study these things find likely is that some passing disturbance gave the cloud a nudge, a shove from outside that pressed a part of it together a little more tightly than before. Perhaps, far off, another star reached the end of its own long life and cast out a great wave through the space between the stars, and that wave, washing over our quiet cloud, gently crowded a corner of it closer, just enough to tip the balance. We do not know for sure, and we may never know exactly, but something, long ago, started the gathering, and once it had begun, it did not stop. It could take hold, because a cloud like that is never perfectly still, and never perfectly even. Here and there it was a little thicker, a little denser, and in those denser places, everything pulled very faintly on everything else, drawing the gas ever so slowly inward toward itself. It is the same quiet pull that holds you gently to your bed tonight, the patient tug that all things with any substance have upon one another. And though it is very weak for anything small, across a whole huge cloud, given enough time, it is enough. Slowly, slowly, over a great stretch of ages, that gentle pulling began to gather the cloud inward, drawing more and more of the gas toward one central place, so that the middle of the cloud grew thicker and denser, and slowly began to warm. And as more and more gas fell inward and piled together at the center, the heat there built and built, and the crushing there grew and grew, until at last, in the very heart of the gathering cloud, the temperature and the pressure climbed high enough to do the one remarkable thing we spoke of earlier. The hydrogen at the center began to fuse. That deep furnace caught and held and steadied itself, and all at once the gathering cloud had a bright and burning heart. A new star had been lit, out of nothing but cold gas and patience, and the slow, faithful pull of everything on everything. That new star was our sun, young and fierce and freshly burning, and it drew into itself the great bulk of the whole cloud, nearly everything there was. The young sun, when it first caught alight, was not the calm and steady star we know. Newborn stars are wild things, spinning quickly, flaring and sputtering, flinging off great gusts and jets as they settle. For a long while, our sun would have been restless and fierce, still gathering the last of its gas, still finding its balance, before it eased at last into the long, even burning that has carried it through the ages since. It took time, a great deal of time, for a fresh-lit star to grow calm. But grow calm it did, and the steadiness we lean on now, the reliable warmth that lets a whole living world exist, was hard won, settling slowly out of that early fury like clear water settling out of a stirred and clouded pool. But not quite everything. Around the newborn sun, a little of the gas and dust did not fall all the way in. Because the whole cloud had been slowly turning as it gathered, the leftovers settled into a broad, flat, spinning disk, wheeling slowly around the young sun like a faint plate of haze. And it was there, in that spinning ring of scraps, from the crumbs left over after the sun had taken its share, that the planets were slowly gathered together, the earth among them. So we are, quite truly, children of the sun's making, built from the same cloud, born in the same slow collapse, kindled in the same ancient dark. When you look at the sun, you are looking at your elder, the great bright heart of the family, formed first and largest, with all the rest of us gathered from what was left. And it has been shining faithfully over its little family of worlds, over you and everything you have ever known, from that first kindling to this very night. We have followed the sun from its birth in a cold cloud, through its blazing middle years, to the steady star that warms us now, it seems only right to wonder, gently, what lies ahead for it in the long ages still to come. And I want to walk through this softly and carefully, because although the far future of the sun does hold great change, it holds nothing at all to trouble your rest tonight. These are the slowest and most distant events imaginable, so far off that they carry no shadow over you, or over anyone, or over any world you will ever know. They are simply the rest of the story, told from a great and peaceful distance. The first thing to know is that the sun is very, very slowly changing even now, though far too gradually for anyone ever to notice. Across billions of years, it is growing, bit by bit, a little brighter and a little warmer, as the helium built up in its heart slowly changes the way it burns. This has been going on for the whole of its life, which means that long ago, in the deep past, the sun was actually a touch fainter and cooler than the one that shines today, and it has been gently strengthening ever since. If you could stand beneath the sun of the far past and the sun of the far future, you would find them both recognizably our sun, and yet the one behind us a little softer, the one ahead a little fiercer. The whole long life of the star a slow and steady climb in brightness, played out so gradually that no living thing could ever mark the change. This brightening is so gentle that it makes no difference across a human life, or across the whole of human history, or across many times that again. It is the slowest of slow changes, playing out over spans of time so long that all of recorded history is less than a single quiet tick within them. But over the long reach of the future, that patient brightening will, in time, matter a great deal. Far ahead, in something like 5 billion years from now, a time as far in the future as the sun's whole life so far has already lasted, the sun will at last begin to run low on the hydrogen fuel in its core. It will have spent, by then, an almost unthinkable span of ages fusing hydrogen into helium at its heart, and the store will finally begin to run thin. And when that happens, the sun will not simply flicker out. Instead, it will change, in a grand and gradual way. Its heart will settle inward, and its outer layers will swell and billow outward, so that the whole sun slowly puffs up to many times its present size, growing larger and larger while its surface cools to a deep, ruddy glow. The sun will become what is called a red giant, a great, swollen, gently reddened star, so enlarged that its edge would reach out across the space where the innermost planets now circle. It is one of the most natural things in the universe. Countless stars have done it, and countless more will. It is simply what a star like ours does in the fullness of its years. I want to say again, plainly, how far away all of this is, because the numbers are so large that they lose their meaning, and I would not have them weigh on you. 5 billion years is not a length of time the human heart can truly feel. Consider that the whole span since the very first simple life stirred in the earth's young seas is less than that. Consider that every mountain range you have ever heard of, every ocean, every creature that has ever lived, all of it fits comfortably inside the time between now and that far, slow change with room to spare. The sun that will one day swell is not the sun of any tomorrow you need imagine. It lies past the edge of every future that could ever touch a single thing you love. Between here and there stretch more ages than have passed since the earth itself was made. so we speak of it only as we might speak of the far end of a very long and peaceful road, seen dimly from the near beginning, with the whole warm length of the journey still ahead, and after that, the ending is gentler and quieter than you might expect. A red giant does not explode or vanish in violence. Instead, having swelled to its great size, it begins, softly, to let go. Over a long, slow while, it gently sheds its swollen outer layers, breathing them off into space, layer after layer drifting away in wide, glowing, expanding shells, the softest and most beautiful farewell you could imagine. For a time, these cast-off layers form a great luminous halo of gas around the fading star, one of the loveliest sights in all the heavens, until at last they thin and drift away into the dark, and what is left behind, at the center of it all, is the sun's own quiet heart, the small, dense, still warm core. All its fire spent, it becomes what we call a white dwarf, a small ember of a star, no longer burning, no longer making new light, simply glowing softly with the leftover warmth of a life well and truly lived. And then comes the gentlest part of all. That small ember does nothing more but cool, slowly, over spans of time longer than everything that came before, giving up its warmth to the dark by the faintest degrees, growing dimmer and cooler across ages beyond all counting, settling at last into a calm and quiet rest. There is no fire in this, and no fear. It is a soft and dignified close to a long and generous life, the way a great hearth, after warming a room all through a long winter's evening, at last burns down to embers, and then to a gentle glow, and then, over the quiet hours, to a soft and lasting warmth in the ashes. That is how the story of our star will end, ages upon ages from now, in warmth and stillness, having given light and life for longer than we can rightly imagine. And so we come back, at the very last, from the deep heart of the sun and the far edge of its reach, and the distant ages still to come, all the way home, to here, and to now, and to you, resting quietly beneath the covers on a small world that circles a steady star. We have traveled a long way together tonight, out to the nearest star and around it and through it, and I hope, more than anything, that it has been a calm and easy journey, and that some part of you has already drifted gently off along the way. Perhaps after all of this, you will look at the ordinary daylight a little differently. It is easy to live a whole life and never really see the sun at all, to treat it as nothing more than the reason it is bright out, the thing that makes us reach for the curtains. And yet it is a star, an actual star, close enough to touch our faces with its warmth, born from a cold cloud in the dark, burning by a quiet trick of the smallest things in the universe, wearing a crown of fire no one fully understands, breathing out a wind that wraps a bubble around our whole world, and giving us, freely and without asking, nearly everything we have. The next clear morning, when the light comes slanting in, you might simply pause for a moment and let yourself remember what it truly is that you are standing in. I would like to leave you with one small thought to carry down into sleep. The sun is not a stranger, hung far off in a sky that has nothing to do with you. It is the source of nearly everything you are. The warmth in your body is its warmth, handed down through the food you have eaten and the air you breathe. The very substance of you was gathered long ago from the same great cloud that made the sun itself, in the same slow collapse in the same ancient dark. You and the sun are old family, kindled together, and it has been shining over you faithfully every single day of your life, whether you noticed it or not, asking nothing in return. So there is nothing at all you need to do now, and nowhere you need to be, and nothing left to think about tonight. The old star will keep its steady watch while you sleep, exactly as it has for 4.5 billion years, and it will rise again tomorrow, warm and golden over the edge of the world, whether you are awake to greet it or still gently sleeping. You are held by something very old and very warm and very patient, and it asks nothing of you but that you rest. Let your breathing slow, and let your thoughts grow soft and quiet, and let the gentle warmth of that far faithful star carry you the rest of the way down into sleep. The sun is shining somewhere on the world, even now. It always is, and it will be shining softly over you when you wake. Sleep well and rest deeply. Good night.